Okay, but if x is equals 2 is opposite of angle A, that changes things. So it doesn't matter which one you call A and B, just labeling it. So this would be 2 because it's opposite of angle A. Y is opposite of B. Hypotenuse is Z. So now the sine ratio is different. The opposite of B is Y. Hypotenuse is Z. And that's supposed to be equal to 1 over the square root of 3. Okay, so this time, the way this problem's set up, there's two variables in one equation that we just constructed, so we can't solve that. Let me see what else we could do. There's a few different ways of doing it. We could set up a Pythagorean theorem equation and solve by completing the square. I did it in I'm not sure if it's the quickest way now. The video I made similar to this. I don't know. Here, let me try a different way for this one. Maybe it'll be quicker. Look, these three sides can relate to each other through the Pythagorean theorem, right? A squared, oh, this is A squared. No, that's A squared. Okay, A squared plus B squared equals C squared. No, that's not going to work because that's not going to be easy to solve. Okay, so what I did in the other videos is sine of B equals 1 over the square root of 3. You can draw a mini triangle. Call this A, call this, let's not call them letters actually. Yeah, we can call them letters. So this is a different triangle, same A, same B, and sine of B is 1 over the square root of 3. So the opposite of angle B is 1, and the hypotenuse is square root of 3. This is not the same triangle, right? That's important to emphasize. What we just drew here is a triangle that emphasizes the sine ratio, but it's not directly equal to. We'd say that this is a triangle that's similar in that the ratios of the sides are going to be the same, but it's not the same triangle. And you can use the Pythagorean theorem to find this missing side. A squared, oh, A squared is unknown, so A squared plus B squared equals C squared. So subtract 1 from both sides, so you get A squared equals 2, or in other words, A equals the square root of 2. Okay, and again, not the same triangle, obviously, because these aren't the same. What you want to do is you want to find the coefficient that represents how to relate these two sides to one another. So how does square root of 2 get to 2? In other words, like if these two triangles are similar, that means you can multiply all these side lengths by the same number. You should be able to get these numbers over here. So to find out what that is, I've got square root of 2 in my smaller triangle. If I multiply that by, let's say, letter C, that should give me 2. And then we can quickly solve that equation by dividing square root of 2 from both sides. And then if you want to rationalize the denominator, multiply the top and the bottom by square root of 2. So that's the number that you want to multiply every side, every corresponding side to get to these letters over here. So what's y? I would multiply the side that corresponds to y by this multiplication factor by 2 square roots of 2 over 2. And that's easy. 1 times 2 square roots of 2 over 2 equals 2 square roots of 2 over 2 for y. And then what's z going to be? I'm going to multiply it by that scaling factor by 2 square roots of 2 over 2. Oh, you know what? 2 I'm sick right now when I make this video, so I missed something. Look, 2 divided by 2 is just square root of 2, so that's a much simpler way. The scaling factor is that you multiply every side length by square root of 2. So that will simplify our life over here. Multiply by square root of 2. So square root of 3 times square root of 2 makes square root of 6. So that's what z should be, square root of 6. Okay, so what we did was we said, okay, this is our ratio. Let's draw a smaller, similar triangle where the opposite of b is 1, the hypotenuse is square root of 3. And we use the Pythagorean theorem to find this side. And then we said, okay, so if this is the sine ratio, then we should be able to multiply all these by the same number to get to these side lengths over here. And when we solve that number, we said, well, how do you get from square root of 2 to 2? You got to multiply it by square root of 2. So we multiplied everything else by square root of 2 to find out these missing sides.